Good evening. My name is Harshita. I am a PhD student at ISA Tirupati. So today we will be discussing the week 0 assignment of this course, Introduction to Abstract and Linear Algebra. So along with the assignment questions, we will also look at a few conceptual details that we will need for the course. So we will start with something very basic. We will see what is a set and how do you denote it. So a set is a collection of well-defined objects. So, for example, you look at set of all letters in English language. Or let us say you look at the set of all countries in Asia. And so on, you can go on listing them. So now we'll look at how do you represent a set. So representations of a set. So the first way of representing it is you just list the elements. So you this is the symbol, this is the notation used for listing the elements. You just say what all it contains. So if you want to say 1, 2, 3, so you put it inside these flowery brackets, or you A, B, C, D, E and so on. So we will look at some basic things which are used in mathematics. So first is the set. When we think about numbers, we think about the counting numbers, right? So that is called the set of natural numbers. So set of natural numbers, it is usually denoted by this n, and this is 1, 2, 3 and so on. So this is the first way of denoting a set. The second way is you actually give a description of the set. Suppose I want to write the set A that I have written here. So we can say A is the set of all x in natural numbers. So you are looking at all natural numbers such that x is greater than or equal to 1 and less than or equal to 3. Right. So this is the same set that we listed here, 1, 2, 3. And so you can give other descriptions of different sets. This is another way of representing a set. Now we have another definition. So a cardinality of a set is the number of elements in the set. So if the set does not have finite number of elements, we say that it has cardinality infinity. So let's look at some examples. The set A that we already defined has cardinality 3, and the set of natural numbers has infinity, or we say it is a infinite set. Okay. Now suppose we have a set. So let's say we have the set that we started with 1, 2, 3. When we say a subset of this, we mean that it's another set, but the elements of the other set are contained in this set. So let us say B 1, 2. So every element in B is contained in A, right? So B is said to be a subset of A. So B is said to be a set B. We'll make a definition. A set B is said to be subset of a set A if every element of B is contained in A. So, and it is usually denoted by B is a subset of A. So, examples would be 1, 2 is a subset of 3, 4 is a subset of natural numbers. Okay. So with this we will look at a few questions from the week 0 assignment. So if we look at question 1, so it says, it asks you to find the cardinality of the set 1, 2. So the question says the cardinality of the set 1, 2 is. So it's just the number of elements in this set, which is 2. So the answer is 2. Okay. If we look at the third question, so we are given a set A equal to A comma B, and B is the set of all subsets of A. Of all subsets of A, right? So then what is B? Okay, so when we say a subset of A, every element of B is contained in A. So there is one thing which is the empty set, which is the set which does not contain any element. So by default this is a subset of any set, right? So we will list subsets of A. So the first thing is empty set. This is denoted by this. So empty set. So just to remember, it is contained in every set. So it is a subset of every set, right? Then what can we have? We can have, so this cardinality of A is 2, so we can have subsets containing single elements, right? So we can have the set A, singleton A, and so these are subsets of A of cardinality 1, and finally we have the set itself, which is a set of cardinality of 2, subset of A so B is empty set, A this set, the singleton set B, and finally the whole set A itself. So let us look at one more example of similar type. Let's take A is, let's say A, B, C, and the question is, what are all the subsets of A? So we will do the same thing. So we have empty set, which is always contained. Then we will have all sets containing only one element, and we have sets containing two elements. So we can have AB, we can have AC, we can have BC. So, and finally we have of cardinality 3, which is only one possibility. Okay. So here our set A had cardinality 2 and our set B, so cardinality of A was 2 and cardinality of B is 4. So let's look at it here. So cardinality of A is 3 and cardinality of, let's say, B is the set of all subsets of A. We will put this later. So cardinality of B is 1, 2, 3, 4, 5, 6, 8, right? So where we will just list B. B is this set of all subsets of A. So if you just notice the pattern, we see that the cardinality of B or the set of all subsets of A is turning out to be 2 power the cardinality of A, right? So this is in fact true in general. You can just verify this result. Okay. Now just a notation or a remark. So an element A belongs to a set if it is part of the collection that the set has. So it is usually denoted by A belongs to A. So now if we look at question 4 of the assignment, it says the number three by two belongs to the set. So there are 4 options. So before we answer this question, we will just look at some fundamentals about the number systems, right. So we have already defined what natural numbers are. We will look at few other definitions. So let me just restate the natural numbers. So this is the counting numbers, which is denoted by n. Then we have set of whole numbers, which is natural numbers, and we have a 0 in addition. So we have this, it is denoted by W, and we have set of integers, which is you have all the negative numbers also. This is denoted by this Z, and finally we have set of rational numbers, so it is numbers of this form A by B such that A and B are integers. Okay. So 3 by 2 is of this form. So here the option would be rational numbers. So this is usually denoted by Q. Okay. So we'll just look into rational numbers very briefly. So we'll look at different ways of writing a rational number or expressing a rational number rather. So let's just look at an example. Let's say 2 by 3, right. So the top number is called the numerator, the one below is called the denominator. We can multiply both by some same number, and what we get is, let's say if we multiply by 2, we get 4 by 6. So these are equal. If we multiply by minus 1, we get minus 2 by minus 3. So all of these are just different ways of expressing the same rational number. So this leads us to something called the simplest form of a rational number. So So this is an expression of the form P by Q. So intuitively we want to consider 2 by 3 as the simplest form, right? So such that greatest common divisor of P and Q is 1. So let's just look at a few examples. So let's say 4 by 6, this would be 2 by 3. Simplest form of 10 by 4 would be 5 by 2, and so on. Okay, let's look at one more example. Let's say 18 by 6. So this is 3 by 1, right, which is same as 3. So just as a note, every integer is a rational number. Because if x is an integer, we can write it as x by 1. So what we are saying is integers is a subset of rational numbers. Okay, let us see how to represent these rational numbers on a number line. So we have the line, let's say we have 0 here, 1, 2 and so on, -1, -2. So we'll look at first example. Let's say 3 by 5. So this interval between 0 and 1, we divide it into 5 parts, and you are looking at the third part. So this is 3 by 5. So let us look at one more example. Let's look at 4 by 6. We have 0, 1, 2. Okay. So we'll divide it into 6 parts. So and the fourth part, which is this, is your 4 by 6. But we know that this is equal to 2 by 3, right? So let's see what happens when we divide it into 3 parts. So we have 1, 2 and this is the final one. So again we are looking at the second out of all these. So this was 2 by 3. So in fact, even when we represent it on the number line, we see that it is turning out to be the same point. Okay, let's look at one more example. Let's look at 5 by 2. So when we say 5 by 2, what is it? When we divide 5 by 2, it goes 2 2s are 4, you have a remainder 1, right? So this is the same as 2 plus half, or rather we write it in this form 2 1 by 2. So, what we do is, so you look at the interval after 2, that is between 2 and 3, and so we are looking at 2 1 by 2, and you try to represent that here. So, you divide this into 2 parts, you look at the first part. So, this is your 2 1 by 2. Okay, one final example. So, let us try to plot 1 2 by 3. So, we have 0 1 2 minus 1 and so on. So, you look at the part after 1, the interval between 1 and 2, divide that into 3 parts, and you look at the second part. So, this is your 1 2 by 3. Or this is in fact, how do you convert it into a fraction? So, you just multiply the denominator with 1. So, it will be 1 into 3, sum with the numerator by 3. So, this is same as 5 by 3. Okay. So, since we are talking about rational numbers, let us also look at what are irrational numbers. So, one way of defining irrational numbers is numbers, or numbers on the real line, which we call as real numbers, which cannot be written in this form. So, whatever is not a rational number is an irrational number. So, in the form of P by Q, where P and Q are integers, is called an irrational number. So, example would be root 2 pi and let us say root 3 and so on. So, we will look at a slightly different way of denoting these or representing this. So, we will see how to convert rational numbers into decimals. So, we will again look at it through examples. Let us take 5 by 2. So, we just do 2 2s are 4, 1. So, it does not go anymore, we put a point, put a 0. 10 divided by 2 is 5, and that is it. So, our 5 by 2 is 2.5. Let us take one more example. Let us say 2 by 3. So, 3 is greater than 2. So, this is 0.20. The largest factor is 6. So, that is 3, 6 are 18. 2, again you put a 0, and so this keeps continuing, right. So, 2 by 3 is 0.666, so on. We'll look at one more example. say 5 by 7. This is 0.7 is 49, 1. So we go 1 times, we have 3, 4, 28, yeah, so 2s are 14, 8s are 56, and finally, so we've got back 5, right? So if you continue, this whole process will continue again. So what we get is 0.71428, the same thing will keep continuing. So the observation that we make here is when rational numbers are written in their decimal form, either it terminates like we had 5 by 2, or the same pattern will keep repeating. So it is recurring. So this can also be used to define what is an irrational number. So we say a real number is irrational if when we express it in decimal form it is neither terminating nor recurring. Okay. And another fact is, let's look at, let's say 0, 1. So you look at the midpoint of this, which is half, right? Then you again look at middle of this, which is 1 by 4, middle of this, which is 3 by 4, then 1 by 8. You keep doing this process. So we keep getting rational numbers, right? So we see that there are infinitely many rational numbers between 0 and 1. And 1, and you can take it as a fact that so we can actually find an irrational number between any two rational numbers. So we can find an irrational number between any two rational numbers. So using this fact we actually get that, so we have infinitely many rational numbers, right? So in between them you can go on finding irrational numbers. So this actually gives that there are infinitely many irrational numbers also in between 0 and 1. So this is one of the questions of the assignment. So it says how many rational and irrational numbers are possible between 0 and 1. So this is question 9. So instead of 0 and 1, let us look at some other interval now. So similar to question 9, how many rational and irrational numbers are there between, let's say, 1 and 2. So we can do the same thing, right? So we have let's say we have 1 here, 2 here. So you keep dividing and taking the midpoints, we get the rational numbers, and using the fact we get irrational. So the answer is infinity. Okay, and we'll look at question 10. So this says, what does z plus represent? So we know z is the set of all integers, and this plus denotes that we are looking at all those integers which are positive. So this would be set of all positive integers. Okay. Look at question 7. So it is asking for the cardinality of set of positive integers. So what is this? 1, 2 and so on. So this is not finite, right? So it has to be infinite. Yeah. So next we look at question 5. So let S be the set of, so S is given to be this set, X such that X is a letter in the word Kolkata. Then the set S is, so when we write set in element wise, when we list the elements of the set, we do not repeat any element twice. When we say it is in the set, we just say it belongs to that set. We don't have to repeat it twice. We don't, count how many times it's coming. So this would be K O L. So although there is another k coming. Since it's already come here, we do not repeat it. So we don't write that k again. So we have A, we have T, and again A is already here. So that is the end of the list. We will look at, let us say, another example. So let us say set of alphabets in apple. Okay. We just don't repeat it. So we get A, P is appearing twice, but in the set we just write it once. So this is cardinality 4. So although apple has 5 letters, as I said, it has cardinality only 4. Okay. So we will now talk a little bit about matrices. So what is a matrix? A matrix is just a rectangular array of numbers. So we will just look at a few examples. So this is a matrix, or you could have matrices something like this shape, or you could have matrices of this shape, or something like this. So we will define something called order of a matrix. So it is basically you count the number of rows and number of columns, and that is the order of the matrix. So order of a matrix is, let us say, matrix A. It is, so we first write the number of rows, so here the cross does not mean multiplication, it is just written as this cross. So let us look at an example, maybe that will make it clear. So if we look at, let us say, 1 1 2, so how many rows does it have? It just has one row, right, and 3 columns. So order of A equal to 1 cross 2. Let us look at this matrix. So order of B, so you first count the number of rows, which is 3, and then the number of columns, which is 2. So this is 3 cross 2. Okay. So we will look at some operation on matrices. So if you want to sum two matrices, you just sum each entry. So 1 2 3 plus 0 1 0, this would be, you just sum the corresponding entries. So 1 plus 0, 2 plus 1, 3 plus 0, 1 3 3. So the first thing we observe is, if we have to sum two matrices, their order should be equal. So next let us look at product of matrices. Okay, we will first do it via an example, and then okay. So we'll do all the entries separately. Yeah. So the first task is, you look at the first row and first column, and what we do is multiply the corresponding entries and then take the sum. So what we are saying is 1 into 1 plus 2 into 0, that will be the entry here. So this will be 1 into 1 plus 2 into 0, and here you take the first row, second column, so that would be 1 into 3 plus 2 into minus 1. Next you take the second row and first column, so that would be 3 into 1 plus 4 into 0, and finally you have the second row and second column, so that would be 3 into 3 plus 4 into minus 1, right. So putting together all of that, so we get 1, 2, 3, 4 multiplied by this matrix 1, 3, 0, minus 1, this is equal to, so the first entry is 1, the entry here is again 1, the entry here is 3, this is 3 into 3, 9 minus 4. So this is how we take product of matrices. So what are we doing here? We are taking this row and this column, right. So in order to take product of matrices, the number of entries in the rows should be equal to the number of entries in the columns, right, or rather the number of entries in each row is given by the number of columns. So what we are saying is, if A is of order, A is a matrix of order m cross n, and B is a matrix of order r cross s. In order for the multiplication to make sense, this n and this r should be equal, right. So for the multiplication, AB to make sense, n must be equal to r. So this happens to be one of the questions in the week 0 assignment. So the second question says, let A be a matrix of order m cross n, B be a matrix of order r cross s, then the product AB is defined only if, and there are multiple options. So the right one would be n is equal to r. Okay. Now we'll then look at a concept called transpose of a matrix. So it is denoted by A, this upper T. So if you have a matrix, so A transpose would be you just write each row, you make the rows into columns. So, the first row becomes the first column. So, we have the first row here is 1, 2, that becomes the first column. Second row becomes the second column, and so on. So, we will look at a couple of more examples. So, here A transpose would be, so if you have the first row is becoming the first column, second row is becoming second column. Let's look at one more example. Change it to B. So, the first row is just one entry, which is 1, that is your first column, second row, and then so you just make an observation about the order. So, if A is a matrix of order M cross n, what would be the matrix order of the matrix A transpose? It would be n cross n. So, then is n cross m, because the rows become columns and columns become rows. Okay. So, one more definition. So, we will define two kind of matrices. So, one is a matrix A is said to be symmetric if A equal to A transpose, and second one, a matrix A is said to be skew symmetric if A is equal to the negative of A transpose. So, we will look at an example. Let us take this matrix 1, and let us try computing the transpose. So, the first row becomes the first column 1 0 2, second row is 0 1 6, third row is 2 6 3. So, we have got back the same matrix, right. So, A is symmetric. And let us look at this matrix. So, what is B transpose? The first row becomes the first column, second row becomes second column, third row becomes third column. So, B is skew symmetric. Okay. So, there is a question in the tutorial sheet, question 8. It says, according to symmetric matrix, which of the following statement is correct? which of the following is correct? So the first option says A equal to A transpose, which is the right answer. Which is in fact the definition of symmetric matrix. So one thing you observe is, if you look at this skew symmetric matrix, so when we take the transpose of it, the entries in this diagonal, they remain in their place, right? So when we say B has to be equal to B transpose, it means each of these B has to be equal to negative of B transpose. It means each of these entries has to be negative of itself. So we'll end with this one observation, that if A is a skew symmetric matrix, the diagonal entries have to be 0. So we'll stop the session with this observation. Thank you.